Okay, so we are almost done. Only 2 slides left in this class. So, in order to understand the last thing we need to do, which is to create this calculated monthly payment or calc MTH PMT method for our mortgage class, we need to talk a little bit about the concept of polymorphism, which is sort of hard to pronounce. We already discussed the interface, which is the set of all the properties, methods, and events associated with a class, and that programming using classes and objects requires that we understand how to work with the interface, but do not bother with how things work under the hood. One of the key aspects of this black box approach, one might call it, is the concept of polymorphism, which is the feature that allows two different classes to have the two identically named methods. Again, think calc MTH PMT or calculate monthly payment with the same purpose to calculate the monthly payment, but different implementation. Another example from the textbook discusses the PF pass-fail student child class that inherits the calc semester grade method from its student base or parent class. Okay, the only modification that needs to be made in the PF students class version of this method, calc sem grade, is that if the student received a grade of F using the student's base class version of this method, the PF students version of it sets the grade to fail. Otherwise, it is a pass. You're welcome to check it out in the book. It's towards the very end of chapter 11. So, this process of modifying the identically named method, as was described in the student grade example, is called overriding. In VB, the override keyword is going to be used with calculate monthly payment or calc MTH PMT method to get it to be overridden from its base version in the case of adjustable rate mortgage that needs a slightly different calculation, as you'll see shortly. So, we go back to the project, switch to the code, and actually go first to the FRM PMT or payment, I should say, calculator, the initial form and its code, and scroll down all the way to the bottom or towards the bottom where we have the class loan right here. And then the first thing we need to do is make the base version of the calculate monthly payment function overridable with the keyword overridable right there. Okay, so we save that change, and then you can close the FRM payment calculator code. Then we go back to the FRM mortgage loans.vb code, scroll to the bottom, okay, and then we create the same function, right, with the same name, or I should say the function with the same name, calc MTH payment, and this one overrides function calc MTH PMT, okay, as double, okay. And then what we need, I'm gonna keep this piece of code here because I'm actually going to be able to use it. What we need is two variables, specifically dim arm date as date, which is going to be the date the interest rate switches from that typically low initial teaser rate to a much higher number. Okay. The second one we need is dim rem prince for the remaining principal as double. Okay, that is going to be the remaining principal as of that date. Okay, so first, okay, this function needs to incorporate two calls to the base calc MTH PMT function. The first one is if, okay, if the type of the loan is fixed, which is accessed through, using my base keyword. Okay, this allows you to get to the type of the loan, okay, and test whether it's fixed as was set up in the main program, as you might remember from the previous video, in which case we do just want to return whatever the base version of the calc monthly payment calculates. Okay, so we're going to have then else and then end if, unless you'd already inserted it. Okay, Okay, so this is simply stating that if the type of the loan, which we can access through this my base keyword, is fixed, then we just use that base version of the calculate monthly payment, which is now overridable as we've done in the FRM payment calculator code. Otherwise, we have to deal with adjustable rate mortgages. So the first thing we need to do is calculate that date, ARM date, as today, and then we need add a number of years defined in ARM term. Okay, so the ARM term, okay, the ARM term, right, is the today in the add years, okay, that should work. So if the ARM term is 3 or 5, we add that many years to today and get the date when the switch is going to take place. Okay, the remaining principal as of that date can be calculated using the base class and its get remaining balance. As you remember, the remaining balance as of any date between the today and the end of the loan can be calculated using this method. Okay, if you give it an early payoff date, which in this case it's really not a payoff, obviously it's just a switch, it's this ARM date. Okay, so that's going to be sort of the new principal in a sense. Okay, so then we're going to reset the base amount of the loan to be this remaining principal. Okay, so it's in essence taking a new loan out, sort of. Okay, and then we're going to calculate the my base term, or reset my base term, by subtracting subtracting the ARM term from the current version or current value of the term, right? So think this is 30, this is 5, 30 minus 5 is then 25. Okay, so for the last 25 years of the loan, you're going to have the pleasure of paying a significantly higher rate as defined by ARM rate property. Okay, so once you have these essentially three parameters that are needed: the new amount, the new term, and the new rate, it's all really like a new loan, as I keep saying. All we have to do then is return my base, right? We call the base version of this function, okay, and do the calculation with these parameters. That's it. So that takes care of that calculation for the adjustable rate mortgage. The function's over, and that is it for this particular class. Okay, so while this is not terribly simple, as you can sort of see, even without that complicated finance, you can kind of tell that there's sort of the interplay here between different classes, different methods. And the code is sort of more robust in the sense we are not redoing all the calculations. We are taking advantage of things we've done before, even for a different reason, and that all goes into better code reuse and efficiency. Okay, so right, so at this point we make sure that the startup form is the mortgage loans. Okay, we're going to start, hopefully it runs, with a conventional 200,000, because we know that if this is a conventional loan, right, you'll notice that we can't select more than one. Okay, if it's a conventional loan, we should get oops, we forgot to display the monthly payment. That's the only other thing I need to do right here. txt, what is it, txt payment dot text equals credit dot calculate monthly payment. Now this is this new function, right, that's overridden and overridable, overriding the old one, to string as currency, right? So that should then allow me to save and run and put the 200 grand again, assume the fixed rate mortgage, and calculate that $954 should be familiar by now. Okay, now if I change this to adjustable rate mortgage, you'll notice that now I have the option to change these. Let's keep 5 years. I also have the option to have two different interest rates, like 3.1 or 3.5. Okay, you'll notice that when I selected 3.5, the 4 that was originally selected is now deselected. That is thanks to this little piece of code that I haven't discussed because I forgot, that sort of caps the number of selections at 2. If the count becomes 3, then we're going to remove the sort of top one in order from top to bottom, I suppose, or I guess the bottom one in that sense. Okay, so if I go with 3.5 or 3.1, I should say, and then something significantly higher like 6. Okay, so now it's not going to let me do that unless I deselect one of these. So let's say 3.5, deselect 3.1. So it's going to make me select only 2. And then the payment should now be calculated based on the 6%, 25 years, whatever the remaining principal out of 5 years on the original mortgage was, and all that finance we sort of don't care about. And obviously it's going to be a higher monthly payment, even though there is 25 years left rather than 30. All right, so that's sort of enough for this. We're going to save this. Okay, we're going to save this, switch back to the presentation. Okay, go to the very last slide of the class, I'm happy to say, and sort of just summarize briefly, saying that this concludes the video series on the object-oriented programming. Way more videos than I sort of anticipated when I started recording these. We defined these concepts of classes and objects and properties, behaviors. We sort of explained on the sort of high superficial level the pros and cons of both procedural and object-oriented approaches, namely that OOP approach has this sort of code reuse and sort of really tight robust type code that sort of builds in this Lego sense with these hierarchies, object hierarchies, as hopefully this last few videos illustrated. Then we use this payment calculator project to basically go through this whole thing, starting with the loan class, then going through those borrowers, right, with containment and events and arrays of objects down to the inheritance and polymorphism and overriding of the calculate monthly payment method. Okay, so after we complete a few additional or several additional in-class examples, you will be ready to start working on the third and the last. I believe this is third or fourth, basically the last, it should be the fourth assignment, the last assignment for this class.